Now, like terms, again, is a very important component of algebra, and it can really help you when you're trying to simplify equations. So I'll just give a quick demonstration here. So 2x plus 3x plus 4. Now, often an equation will tell you to simplify as far as you can. So this is not fully simplified. Now, I want you to pause the video and try and work out if you can think why. If you didn't, that's okay. That's why we're here, to teach you about like terms. So this 2x here and this 3x here are like terms. Now, can anyone think why? So just pause the video and we'll try and work that out. So it's actually because it's got the same pronumeral. Doesn't matter that there's a different coefficient, it's because it's got the same pronumeral. So what this actually is 2x is actually x plus x, and then 3x is equal to x plus x plus x. So here there's actually 5 x's. So what you can actually do is you can add these two together and get 5x plus 4. So essentially when you see two terms with the same variable and pronumeral, what you can do is just add the coefficients together and you'll find that you can get the simplified version. Now there is a trick though. If you see this equation, 2x plus 3x squared plus 4, you can't actually simplify that further by using like terms. Why? Because the x squared and the x are not the same pronumeral. Yes, they both have an x, but the x squared is actually x times x. So there's 1 times more x than in the 2x. So that's why you can't actually add them together. So essentially, all you have to remember is that only terms raised to the same power are like terms. So what I'm going to do now is I'm going to give you guys a question. If I say that 4x plus 2x x. So just pause the video and try and work that out. You can take your time. This is a new topic and it can be difficult at the start. So how would you do this? So essentially, first what you do, so your first term here is this 4x over here. So what you do is you find all the x's. So you've got a 4x here. Let me just use a different color. You've got a 4x here, a 2x here, and a minus 3x here. So what do you get? 4x plus 2x is 6x, and then 6x minus 3x is equal to just 3x. Now, what about this x squared over here? Is there anything else in the x squared? No. So it's 3x plus 3x squared plus, now if you look at this y, there's 2 y's here. So there's a plus 2y and then there's a minus 4y. Now again, I've already put in the plus, but there shouldn't be a plus there, because it actually is minus, because plus 2 minus 4 is minus 2. So what you have to do there is that's a minus 2y, and then there's just the 1y squared. Right. Now this topic here, multiplying and dividing algebraic terms, is one of the most integral topics in algebra you can ever do. So let me give you an example here. So let's say we have 3a. Now you can simplify this because it's not an addition. So you can multiply things together as many times as you want. Now, so to find the value of this, what you have to do is you have to multiply the coefficients together first. So 3 times 2 is equal to 6, right? Now then you have to multiply the pronumerals. So if there was, say, a b here, then it'd just be 6b times b, which is 6b squared, right? But because there's an a here, you can't do that. As we learned before, a times b is just ab. So 3a times 2b is equal to 6ab. So that's how to multiply algebraic terms. Now dividing is a bit more different. So let's say that we've got 6abb, right? Now, so these are all factors because it's multiplication, and in a multiplication, whatever you're multiplying it by is all factors. So this 6 is a factor, this a is a factor, and this b squared is a factor. But that b squared itself is a factor of 2 b's. And on the bottom, the 2 is a factor and the b is a factor, right? Now, in divisions like this, you can actually cancel out factors that are on both sides. So what you can do here is, so the 6 and the 2. Now 6 is a factor of 3 times 2, and 2 is a factor of 2. So you can get rid of the 2's. So you get rid of the 2 there, and you get rid of the 2 there and replace that with 3. Now with the a, there's nothing on the bottom, so you can't do anything with the a. Now with the b squared, so this is where it gets interesting. So b squared is actually equal to b times b, and this b is just a simple b. So there's two b's in this one, but there's one b on the bottom. So what happens then is the top just becomes a single b, and the bottom doesn't have any b's. So essentially what it becomes is 6ab squared on 2b is just equal to 3ab. Alright? So I'll give you guys a question here. It could be difficult, but just try it. So 3a times 4ab on 12ab. So just have a go at that. Okay, so let me show you how to do this. So 3a times 4ab. So first, again, we've got to multiply the coefficients. So 3 times 4 is equal to 12. And then a times ab. So a times ab is actually equal to a squared b. Because what is there? There's two a's and a b. Alright? So that's a squared b on 12ab. Alright? Now we can cancel stuff out here. So we can cancel out. So the first thing we can cancel out, that's pretty obvious just by looking at it, is the 12 and the 12, and then the b and the b, right? And as we did here in this other equation with the b squared and the b, you can do the same thing with the a squared and the a. So if you get rid of the squared side and get rid of the a, what it becomes is literally all that's left is an a. So your answer is a. So this is the last section of the algebraic section of this course. So as you can see here, our last topic is expanding brackets. Right. So the distributive law is a law that states that if you have an equation that says this, a, b plus c, then essentially how you work it out is a times b and a times c. So what this is equal to is a times b, which is a, b, and then a times c, which is a, c. So now I'll give you guys another example. So if you have, say, 3 plus b, right, this would be equal to 3a times a. Now what's that? So there's no coefficient in front of the a because there's a 1. So 3 times 1 is 3. And then the a times the a is a squared, right? And here again, there's no coefficient in front of the b, so it's just a 1. So 3 times 1 is 3. And the a times the b is an ab. So 3a outside of a plus b is equal to 3a squared plus 3ab. So I'll give you guys one question, and this will be the last question for this video. So just have a go at that. How we do this? So there's no coefficient in front of the first a. So what happens is 2 times 1, which is 2. Now a squared times a. So the indice law states that if there is two numbers that you're multiplying and they have a power, so a squared times a in this instance, so that second a is a to the 1, this would be equal to a to the 2 plus 1, which is a cubed, right? So if you can take this over here, 2a cubed, and then plus, so there is a coefficient in front of the b, it's a 4, so 4 times 2 is 8, and then a squared times b is just a squared b. Well, that brings this video to an end, and I'd like to thank you all for watching this video. Please feel free to like and subscribe, and also comment any questions you may have. If you have any further questions or doubts that you'd like clearing up, please feel free to go onto the EduConnect website, which will be linked in the description, and sign up for one of our free plans, where I'll help you by using video calls to clear up any doubts you may have.